All right. Hi, everyone, and welcome back to this week's episode of Pulumi Office Hours. As always, I'm Luke Hoban, CTO at Pulumi. I'm just going to spend the next few minutes talking a little bit about some of the things that are new with Pulumi and some of the questions that have come up over the last week or so in the community discussions and discussions with users and customers, and talk about a few of those in a little bit more detail, maybe do some live coding and that sort of thing. So again, for folks who haven't checked out Pulumi before, you can get started with Pulumi at pulumi.io. Install, get started, learn, whatever you want to do here. One of the things, of course, we have our blog. I'll just cover a couple of the things we've announced launched recently on the blog first, and then I'll dive in a little bit more detail on a few things. So one, just today, actually, this morning, we announced support for Atlassian identity. And so previously, folks could log in with GitHub, and about a month ago, we supported GitLab as well. Now support Atlassian identity as well. So no matter what, where your source code is, no matter what kind of team environment you have, very easy for you to connect up to the Pulumi.com backend service and easily manage your Pulumi deployments. And so for folks who are using Atlassian, we've talked to many users and customers using Atlassian who have asked for this, and so now that is a possible sign-in option. And of course, for signing in, is one thing. We actually then have a lot of capabilities that hook into other parts of your source control system, give you links back into your source control for your deployments, that sort of thing. And so definitely encourage folks to check out the Atlassian identity if they're Atlassian users. And also check out some of the features that are available for folks connecting into their source control within app.pulumi.com. So you can read the blog post, see a few examples of some of the things that are available already, like the CI integration there. All right, so that's a nice one. Just opens up access to some new users as well as folks who have been using GitHub and GitLab. The other blog post we put out earlier this week, or maybe it was last week, was the blog post on using our EKS package with Pulumi. So one of the nice things that we showed off in this blog post is just how easy it can be to install a fairly complex thing like EKS. So EKS is a very nice managed service for doing Kubernetes deployments from AWS. But the getting started for this is actually fairly complex and involves a multi-step process of spinning up the Kubernetes masters using EKS, then spinning up some EC2 instances, then deploying some stuff into your Kubernetes cluster, a variety of different steps you've got to take. They're fairly complex. And so with our Pulumi EKS package, we actually make that just kind of one step. You can either run it just to install an EKS cluster with a single command, or you can write a very small kind of program to customize that, to say I want to create a VPC and then I want to create a cluster with this small set of configuration available here. And so overall, just a really easy way to use EKS for folks using this. And this has been something we've actually seen a lot of users being very interested in right now, is the ability to do this. And Kubernetes is actually really well suited to kind of some of the things that Pulumi can do really nicely here in terms of managing your infrastructure. So that's definitely, if you are interested in using EKS, or if you are doing Kubernetes plus managed cloud in AWS, definitely encourage folks to check out that blog post and go into a little bit more detail. So those are two great things we've done recently. A bunch more features kind of that are coming up soon that we'll talk about in the coming weeks. So when I reached out to folks in the community yesterday, I think, about kind of topics to go into detail on here. One of the things folks pointed out was, hey, we've talked a lot about kind of AWS over the last few months here, and we've talked a lot about kind of some of the simpler serverless scenarios and really quickly getting up with a sort of serverless application or an HTTP endpoint. We haven't gone into as much detail on Azure and GCP or on Kubernetes. And so I thought today I'd spend some time just kind of trying out a few of those things, doing some live coding using those libraries, and showing off kind of what some of the Pulumi experience looks like for both GCP and Azure, and kind of at that intersection with containers and Kubernetes, which is where a lot of folks that we've talked to recently are kind of trying to do interesting things with Pulumi. And so I'll show just a bit of some of how that works and some of what is available there in Pulumi. So first off, for folks kind of getting started with this, no matter what platform it is you're targeting with Pulumi, the best thing to do is really to come in, either jump in onto one of these icons here for the platform you're interested in, or go to getting started and then find the platform that you're interested in. And so I'll start with Google Cloud Platform, and so we can come into the instructions here. And the landing page here gives us some of the key things we need to know, some of the examples we can go look at for sort of a full running app. sort of very minimal, like, what does the simplest possible program look like? Some links over into the ABI documentation for those libraries. And then finally, kind of some of how we can configure the providers so that we can connect up our deployments to the particular projects and accounts and credentials we want to use to deploy to that. And so this is definitely a good place to kind of get started, to orient yourself as you're starting up for the first time using any one of these platforms, whether it's AWS, Azure, GCP, Kubernetes, OpenStack, or any of the other platforms that we support. And so what I'll do is actually come over here and just kind of go to a kind of a blank slate and just kind of from scratch work through building up an example that uses GKE. And actually, what I'll do is first show, we actually have a fully functioning sort of example here of using Google Kubernetes Engine. Just click on this. And this is in our examples repo. You can come in here. This is sort of, shows how to spin up the Google container cluster, how to, set up some of the configuration that you might want, and then finally how to deploy some resources into that. So we're largely going to kind of recreate some of these pieces, but if you want to see something that's sort of the finished working example of this, I'd encourage you to kind of go just look at that example. But just to give you a feel for what this looks like going from zero, I'll start just from scratch here. And so I can do something like here, Pulumi new. I'm in this empty folder GKE demo. And actually, I'll just bump up the fonts a little bit here. What I can do is come and pick out the GCP TypeScript example to start with, and this will just give me a very simple project to deploy on GKE. Now, you notice it asks for the GCP project to deploy into. Well, I happen to, in the account that I have credentials for locally on this machine, I happen to have a Pulumi development project. This would be dependent on kind of what projects you already have set up. And of course, with Pulumi, you can manage your projects as well if you want to create a custom project and then deploy resources into that. But for me, I'm just going to make sure I use an ambient project and one that already exists. When we do that, we'll see that now I get prompted to, with a simple, this template just deploys a GCP storage bucket. I'll just go ahead and say yes to deploy that, just so that I get something deployed and can get a feel for what things look like right away. You'll notice I have this file as well, which describes this templated project that I created. So I'm just importing the GCP library. I am creating a storage bucket, and I'm exporting its URL. And so now we've got a Google Cloud Storage bucket deployed. As always, I can also come over here and just see, what resources are part of this project, so that that storage bucket is right here, and all the details about it are inside the console. Okay, but what we wanted to do instead was actually create a GKE cluster. So let's kind of like play around with this and see what we might want to do. So the first thing we can do is to just sort of say const cluster equals new. And of course, the sort of first thing you can do here is just use the IntelliSense and things to kind of figure out what is available here. And so I type in containers, and we see that there's kind of two things. So I type in container, and now I've got a cluster here. So reasonably easy to kind of go and find that. You notice we've recently added examples into our documentation, and so those also show up nicely kind of inside the tooltips here. So as well as me getting kind of an overview of how this works, I can also see an example of kind of what a real use case of it looks like. And this gives me a good sense of how to use maybe this master auth, what kind of values am I supposed to provide there? How do I do node config, that sort of thing. So let me call this cluster, and now I'll just go ahead and create this. And so, there's a bunch of different options available here. One that I'll need to do is set up the zone. Well, actually, what I'll do is I'll just show, it looks like I can call this with nothing. And so I'll just see what I can do with that. I'll say cluster.id. And so I'll just create that and deploy the cluster ID. I'll just say Pulumi up to go and deploy this. And it should say that we're going to create this cluster and we're going to delete that bucket that we're no longer using. And so we get kind of exactly what we expect there. You should notice, of course, this is a desired state model. And so that bucket that's no longer here, we no longer have that in our desired state. And so it's going to get removed as we go and move to that desired state. And of course, as usual, I can see the details and see, what settings I'm passing here for those different things. So we noticed that it immediately tells us that this cluster cannot determine zone, set in the resource and set in provider level zone. And so the only reason I didn't get a static error here is because I could actually have this provided through some ambient configuration. So I could do, Pulumi config set GCP zone US central 1A. And so I could do this to just set it ambiently so anything that needs a zone can default into that. But instead of doing that, I'll actually provide it directly in line here. And so I'll say US Central 1A, which is one of the zones available in Google Cloud Platform. Now, what I'll do is I'll actually say skip preview here for the next one so that I don't, instead of seeing the preview and then doing the update, since I'm kind of in this just development mode, I'm just going to quickly go through and try the updates every time without looking at the preview. I wouldn't want to do this if I had sort of real infrastructure I cared about deployed. But as I'm just building up my infrastructure and I don't care if something goes wrong, it's faster to kind of do that in the inner loop. So you notice I get another error that initial node count must be greater than 0. So I can come in here and say initial node count is 3. Just try that again. Now we're going to go ahead and create that cluster. So one of the nice things, obviously, about Google Kubernetes Engine is these things spin up very quickly. So this should only take, I think it takes 2 minutes or so. But while we're doing that, let's kind of look at like what the next thing we'll want to do is. So one of the nice things in Pulumi is that we can, as well as creating this GCP resource to create this Kubernetes cluster, we can actually create Kubernetes resources. And so, for example, I can come over here and say, I can say Kubernetes from Pulumi Kubernetes. And of course, I need to actually make sure, I'm going to open up another window here, and I'll just say npm install Pulumi Kubernetes. Since I'm using JavaScript here and Node, I can just npm install any of the Pulumi libraries to get access to those capabilities. And so in this case, Pulumi Kubernetes gives me access to all of the different APIs available in Kubernetes to use those to deploy things as well. And so now I have that available, and we'll see I've got this Kubernetes here. And so what I want to do is now I want to actually connect up to this Kubernetes cluster that I'm in the process of creating on GKE, and I want to use that to deploy things into the Kubernetes cluster. And so the first step I need to do is to create a provider. And so I can say new Kubernetes.provider. And what this does is it gives me an instance of the Kubernetes provider that is connected up to that cluster. And so I'll call this GKE. You see, I can do that using a few different things. I can say, cluster context namespace. Kubeconfig is sort of the easiest one to use. That lets me specify the entire sort of configuration I want for that cluster. Now, one slight challenge is that on GKE, unlike on AKS and some of the other platforms, they don't actually expose. I might want to have a kubeconfig available here, but there's nothing with that name. And so when I stand up this cluster, it doesn't expose as a property the kubeconfig I need to use to access it. So if we go back to that example that I showed you, it actually had a little solution to that built in. That's some code here that describes I want to manufacture a GKE style kubeconfig, which is sort of a unique style of kubeconfig that's hooked up to some of the specific things that GKE does. And so this is, for folks who are familiar with GKE with Kubernetes generally, this is mostly kind of a normal kubeconfig file where we've just templated in some of the things that we do get from the Kubernetes cluster. So the cluster's CA certificate, the endpoint of the cluster, and some information about the context. So let me just go and grab that. I'll put it over here. So I'll just say the kubeconfig is this, and I think I didn't call it, I called it cluster. So let's just we'll grab the cluster's, grab the cluster's name, grab the cluster's endpoint, and grab the cluster's master auth. Okay, so now that I've got that, I can do KNS config. Okay. So now I've created this provider, and I can use that to then deploy resources. And so, for example, in this case, I can say const deployment. I'll just try to do the simplest deployment I can to Kubernetes. So now I can say kubernetes.v1.apps.v1. And again, like we see, the completion lists here give me access to sort of seeing everything that's available inside Kubernetes. In this case, I'm doing an apps v1 deployment, and I'll call this nginx. And now I can go and see exactly what I need to specify to define a legal deployment. And so in this case, I wanted to provide the spec for the deployment. I want to provide the, let's do the template for the deployment, which will be what I want to actually specify. And in that, I want to specify the tags for the deployment. So let me actually do some Nginx labels. So I'll create some labels I can use here. And in the metadata, I want to set the labels to be the Nginx labels. And then I think I need to specify a selector somewhere. There we go, selector, and I'll select match labels, Nginx labels. Oops. Can't spell the word labels. Okay, so so there we go. I've set up some basic Kubernetes deployment that has a selector which will pick up all of the pods with this label, and then a template which will template out each of the pods inside my thing. And so I can say replicas 2 or something to stand up 2 of those. And now I want to actually specify the spec for the containers themselves. And so this is where I'll do things like, is this right? Yeah, the pod spec, okay. And so inside here, I will do things like containers, and then I'll say image Nginx. Okay. So we can see what, name, I also need a name. Okay. So pretty quickly, you see there, I got a few of those benefits of using the IDE, getting those error checking on the fly, getting tooltips and help. I can see that this containers thing is a pod spec. I can come in here and I can click through these things and see exactly all the documentation on what I want to use. So very handy to be able to do that. But now I've created this deployment, which will deploy 2 copies of the Nginx container into my cluster that I just described. Now, we see that that deployment I was doing previously actually succeeded, and so 2 minutes, 28 seconds deploy the Kubernetes cluster. And now if I do Pulumi up-skip preview, what we should see is we now also deploy, oh, actually there's one thing I'm gonna cancel that really quick. One thing I wanna do is make sure that I deploy this into my, oops. I wanna make sure I provide this into my, what did I call that thing? Provider, okay. I'll call it KDS provider. So this provider that I have that is my connection up to Kubernetes, I want to make sure I use that to deploy into. And I want to do that so that instead of picking up any potential Kubernetes cluster I might have available in my ambient configuration, I want to specify this specific one that I just created within this program. So let me go ahead and do that. We'll see we created that provider, and now we're going and creating the deployment itself. And so we'll see when the deployment stands up, waiting for the replica set to be marked available. A few more things happen. Okay, there we go. And now we've actually deployed that. So what we should be able to see is if I come in here, let's open up the Google Cloud Console. We're in that same Pulumi development project that I was just talking about. Let's go over to Kubernetes Engine. Look at our clusters. I think this is the one in US Central 1A that we just stood up. So I'll go in here. And now if I guess I've got to go look at the workloads on here. Oh, there we go, Nginx. So this is that, that cluster we just saw. I'm running this Nginx deployment. There's 2 of 2 pods that we just described. So we can see all that information about my cluster that I just stood up and the deployment I did into it. As you see, that's pretty quick, just in, a handful of lines of code here, been able to stand up a Kubernetes cluster and actually deploy some stuff into it, all using a single kind of API, and that's a nice thing. I can of course now combine that with doing things like, I could, go back and recreate that bucket, for example, and say new gcp.storage.bucket, or I could create a new gcp.sql.database. If I want to create a managed SQL database inside GCP, I could do that, and now I could reference, I could grab the connection strings for that database and pass them as environment variables into this deployment of my application image. It's really easy to combine the best of your managed services inside GKE and inside Google Cloud in this example, with kind of that Kubernetes as the API for doing my compute. So I could just complete this example really quick and try and get something that I can show off end to end. I'll just say service equals new Kubernetes.core.v1.service. This will give me a service endpoint that I can use to target this thing, and so I'll also call this Nginx. And here I want to do spec type. I'll make this a load balancer. And I want to make the selector be, what type is selector expected to be? That's just my Nginx labels. Okay. So this will create a load balanced service targeting those labels. And so let me just see what happens if I now go and stand that up. I need ports. And I can go again, and I can see, what is ports expecting to be? It's expecting to be a service port, which is a required port, and then optional name, node port, protocol, and target port. So in this case, we know that our image exposes port 80, so we'll just say okay. So I'll just go ahead and do that. I'll just format this so we get nice indentation, and I go ahead and try that one again. This is going to take all the containers that map this Nginx label, which is these two above, and just expose port 80 of them on the load balancer that we create. And so the service is, finding the pods to direct traffic to. So it's going to try to find those two pods matching Nginx labels. Now it's attempting to allocate an IP address to the service. So that's because we have the load balancer. We actually have to, allocate a load balancer in Google Cloud and point that at the service. And you notice that this is a nice thing that we provide this sort of status here. So unlike, using kube control or something to deploy these, where you just kind of put these, you say throw these at the API server and don't get any feedback about kind of what the status is. Here we're actually giving you status on kind of what are the key steps we need to take to get this thing to be healthy. And giving that feedback immediately here. And so after a few seconds, we see it succeeds and gets created. And so now we've actually got that service running inside our cluster with a load balancer in Google Cloud connected to it. So I can export sort of the endpoint for that Nginx IP. And so I can do service.status. So the status will actually be populated because we wait for it to finish deploying. The service is actually populated with the running status of the thing. And so I can say status goes to status dot, and we got load balancer information on there. We got ingress, and then we've got an IP. So I can just do that, run this again, and we should now, we need to export that or else it won't work. So that said nothing was changed. This time we are going to export the load balancer ingress IP address off of that service we just created. And now we see that it's running at this endpoint. And if I curl that, we should see we get welcome to Nginx. And so there, we've actually stood up a service running. This could have been anything I want. I could have stood up WordPress. I could have connected WordPress up to that managed SQL database. You can imagine taking this further. You can imagine taking your own apps. And if you want to get those apps running really quickly inside Google Cloud, for example, doing this is a simple way to take your app, get it running inside a kind of robust Kubernetes-based environment on Google Cloud, taking advantage of load balancers and a variety of other managed services as part of that. And again, the key thing is here you have the full flexibility. So you now can go and modify anything you want here. You can modify things in that Kubernetes cluster itself. So there's lots of different capabilities around configuring the Kubernetes cluster, and you can go and configure any of the Kubernetes resources. And so all of that is available from within that one plane there. So okay, so that was a really simple example using Kubernetes. Folks also asked about Azure, and I thought for Azure I'd show something kind of a little different, but similar. One of the things I actually love, someone actually mentioned this exactly, and I'll just install this while I'm talking. I'll install the Azure package so that we have access to Azure resources as well. One thing that folks actually raised was, talking about containers inside Azure is actually a cool capability in Azure called Azure Container Instances. And that's the ability to just run a container directly in Azure and get an endpoint to it without having to do a lot of this work about standing up a Kubernetes cluster and all of this sort of infrastructure you need to run that. This is a really simple way to go from zero to nothing with a container. And so I thought that'd be a nice place to show off to show up Azure. And so let me do this sort of the simplest way I might imagine trying to do it. So I'll just say Nginx instance here. And I can say new Azure.containers. And again, we have Azure Container Service is our namespace we find for that. And we have a Kubernetes cluster resource here. So Azure has the Azure Kubernetes cluster, and we could use that to do effectively what we just did below for Google. But we can also use a thing called groups. So this is a Azure Container Group instance. The terminology here is a bit funny because the product itself is called Azure Container Instances, but it's published by Azure underneath this name here, which I honestly don't exactly understand, but naming aside, very cool feature here. And so you see the things I can do. I can just specify I want to run some containers. And so those containers, I want to have the Nginx image. We'll see I actually get an error, and it tells me kind of some of the other additional things I need. So it says I need CPU, memory, and name as well. So let's make sure I provide those. And again, actually, I can do something like this, and I don't know off the top of my head whether these are strings or numbers or what, but I look at this and it says, type string is not assignable to type number. So these looks like these are not numbers. So I'll give it one CPU and presumably 1 GB of memory. And so there we go. So now that kind of worked, except it's now telling me I need OS type, location, and resource group name as well on my resource. And this is something about Azure. Effectively, all resources inside Azure need to be allocated inside a resource group. And so let me just go ahead and create a resource group, azure.core.resource group. And I can actually specify the location I want here. So I'm going to say West US 2 there. And so now what I can do, and almost all resources will end up needing effectively this. I can say resource group name is resource group.name, and location is resource group.location. Now I could actually have this resource be in a different location than the resource group, but I may as well, for now, keep these all the same. And then OS type, I can specify Linux. And again, if I click on this, we can see, allowed values are Linux and Windows. So really easy to see that right in line there. Okay, so now I'm not getting any errors. So that was a quick way to kind of get that inner loop, figuring out what I need to do to create that Nginx instance. So let me just see what happens if I deploy that. One interesting thing you notice is I'm doing this in the same program, so I actually still have that GKE cluster and those deployments and services available inside GKE. I'm also deploying resources in Azure from the same program. That's a really nice thing as well, that I can, if I do need to manage resources across multiple clouds, I can do that. I can have clusters in 2 clouds and then deploy things to both of them from the same program. A lot of flexibility in how I do that sort of thing. Now, the way I'm currently authenticating here is just using my ambient credentials on the machine. I could specify explicit credentials as part of my configuration, and that's all kind of specified. If we come back over into these sort of pages, so all the ways I can configure it, so the client ID and client secret, or some of the other options I have for specifying my credentials. But instead, I just want to use the local credentials on the machine so that I can take this and run it in CI if I want and pick up the credentials that are available inside that environment. But to do that, I'm going to need to kind of run AZ login. Azure logs me out I think it only keeps these things live for 30 minutes or something. But now I'm logged in, I get those credentials, and I should be able to continue to run that deployment using my Azure account. Okay, so I'm creating that resource group that's built. Now I'm going to create the container instance. So the ports in, okay, yeah, so it says ports cannot be empty. So let me just set the ports. I'm just going to say port 80. So I'm going to expose port 80, and I'm going to set I think it's IP address type. So I'm going to expose this actually out to the internet. So I think this allows me to specify public. Yeah. So the string public is legal there. So let's try that again. So what this will do is actually give this running instance a public IP address and expose port 80 on the container to that. And so very quickly, actually, that completed. I've noticed that Azure lets that complete slightly before the instance is actually running. But behind the scenes, they're going and spinning up some compute to host this instance. and exposing an IP address that's going to load balance that. And so I hit that IP address that I got back. Oh, actually, it's the wrong IP address. That was my other Nginx. Let me just say export const Azure Nginx IP equals, and let me grab Nginx instance IP address. Okay. I'll just run that update again to get the output out. And now I've got this new output as well. And so let me curl Pulumi stack output. There we go. Sounds like it might still be launching here. Oh, there we go. Nope, we hit it. So we hit the endpoint finally and got back the same content from the Nginx image. So there we go. We have Nginx now running in Azure, just with very few lines of code using Azure Container instances. That's a really nice just capability of Azure. A really simple thing to kind of show off what the workflow looks like for that. But you can also do all the exact same thing we just showed with Google Cloud using Google Cloud instances. And of course now. I can go and take this, if I do Pulumi stack, you can sort of see the details of this stack. And of course, what folks end up doing from here is, taking the stack, and this stack represents kind of my base layer of infrastructure, maybe my container cluster, my Kubernetes cluster, some of my core infrastructure, like my databases, that kind of thing. And then maybe they rebuild additional Pulumi stacks, which represents, and projects, which represent some of the kind of applications they want to deliver. So maybe each application will be its own project, which maybe has a few different instances, and they can actually deploy on top of that. And so you can split up these applications into a few different stacks as well to work across those things. So yeah, so that was a quick tour of kind of some of that intersection of Azure and Google Cloud and Kubernetes and containers. So hopefully there were some sort of interesting new things there for folks. Happy to dive deeper into any of those topics in future live streams as well. Just to some notes, we're going to keep kind of doing the live streams weekly for the next few weeks. So definitely let us know if there's topics you'd like to see kind of a little bit more depth on. And also we're going to be doing a webinar with AWS and with one of our early Pulumi users and customers, Learning Machine, I think it's next week. We'll add it to the notes here. So definitely encourage folks to check that out to go into a lot more detail on some of these cases, especially around AWS and Fargate and that sort of thing with Pulumi. And folks in Seattle, we're doing our first our inaugural Pulumi user group in February. So definitely anyone who's in the area, definitely drop us a note and come and join us for that. And we're going to be hopefully expanding out into some other regions. So if you want to host your own user group in your area, or want us to swing by and host a user group, just let us know, and we'll get that set up. So thanks everyone for joining again, and we'll see you next week. Thanks. Bye.